Hello everyone, this is the announcement video for homework 3. Now here we have two questions in our homework and they are actually you are going to use MATLAB for them, but the output will be a PDF file where you generate your PDF. So it's kind of like an exam, but you have the MATLAB support with you. So the first question is as follows. We have a closed loop step response of a mass spring damper system depicted in figure 1. So there's this mass spring damper system. We have a certain controller and the closed loop, and the result of the step response of the closed loop is given in figure 1. So this is basically a closed loop step response. And the first task is to determine the transfer function of this step response, which is the closed loop step response. You can use the time domain characteristics, settling time, overshoot, etc. in order to find a transfer function for this. So you can see that the grid is a minor grid, so make your measurements, then report your measurements, and based on your measurements, give us a transfer function. So explain that step by step. You can use settling time and overshoot to kind of fit a transfer function to this. Of course, you can also see that it has a steady state value. So yeah. So here you will give us the measurements, the approximate values that you have acquired based on those measurements, and then give us the step-by-step explanation on how you acquired the transfer function for this. So basically, if you apply step, you can check back if you are, since you're generating a report, once you have done that, apply step to it and see if it's similar to this or not. So, and the next step assumes that the closed loop transfer function TS is known from step 1, and we have a p-type controller, kp equals 2, and we have an open loop transfer function GS in a unit feedback loop. So it's basically the same here. We're talking still about the same system here. And the resulting step response is given in figure 1. So it means that you should calculate the open loop transfer function. Since you know the controller, you know that it is a unit feedback loop, and you know that there should be a GS, you can just write out, calculate what GS is. So again, give a step-by-step explanation of this. Now in the next step, there is a refinement. So it says that you should refine GS in order to match the closed loop step response with the given step response in figure 1. And it also asks you to explain the reason why it is needed, or what really here is going on. We know that it is a mass spring damper system, and since you are going to measure stuff here, you will have some errors in your calculations, but you can maybe tweak your process a little bit in order to match the closed loop step response here. So this might be a little bit tricky for you, but since you will have the open loop, you will have the controller, you can then exactly see what the output should look like. You then can tweak your open loop transfer function a little bit. Maybe you're going to tweak your open loop transfer function, or maybe you're going to tweak the TS that you wrote down in the previous step here. So that part is actually the question here. What should we tweak? How should we tweak it? And how can we acquire the almost perfect transfer function for your open loop? Because in the next step, you're asked to calculate the mass, the damper coefficient, the spring coefficient. So M, B, and K need to be calculated in the last step here. So since we know what the mass spring damper system transfer function looks like, you should kind of tweak your system towards that so you can calculate basically the parameters here. So it's kind of more of an engineering question than a coding question, but you have the support of MATLAB. And you have a little bit control knowledge. Question 2 is basically against something similar here. But in this case, we have two-step responses for different, again, p-type controllers. And the positive value or positive coefficient here, we have 4.5, and we result in this step response here. And the negative part, where we have a negative coefficient for the p-type controller, we kind of get this behavior here. You can still measure stuff on this. So as you can see, we have a minor grid. This means that you will have some measurements. And the question is as follows. The closed loop step response, again, we have a closed loop step response, but now we have a third order transfer function. In Q1, we didn't talk about the order of the transfer function, but if you look at mass spring damper, it should be obvious. So basically, that should be obvious here. But here we have a third order transfer function. And again, we are placing it in a unit feedback with a p-type controller. So basically in Q1 and Q2, you have the same structure, a controller, a summation point, and a unit feedback. The system, the controller, they are intact. You are looking at the closed loop step response here. Now, we have two different closed loop step responses, one for 4.5, one for -8. And the question is, what is the transfer function GS? Again, you will write a report, and in your report, you have to explain what you did, why you did what you did. So basically, these two aspects are important. The necessary steps, the decisions that you make, you should explain them very well. The numerical parts can be given in a short manner, but the most important thing is I have measured this. The amplitude is 0.65. I don't know, I'm just making up numbers now, but the amplitude is measured 0.65. The frequency is that. Therefore, I've defined this sine wave, and then I've done this, and therefore it is this. So you should give us the choices and the reasoning behind that, and your measurements, when you refine it, how did you refine it, etc., etc. So it's simple to explain this homework here. It is less about coding, but you have the full MATLAB support here. But it's more about control system and a little bit of reverse engineering. Yeah, that's actually all about the homework here. You might want to take your time doing this homework, but hope that it will be fun for you, because reverse engineering has this fun aspect about it. So that's it. Good luck.